Hello everybody, welcome to my channel. Today we'll discuss about a completely randomized design using the ExpDes package in our software. And in the previous tutorial, if you remember, we tried to discuss about randomized complete block design using the same package. So today we'll continue on CRD. So as usual, you have to load this package, which stands for experimental design, and the model for the completely randomized design is here. Is you have to follow. So if you know that the model of CRD is treatment and the error. So here is the treatment, then is followed by the response variable, and here is the qualitative. That means we are assuming that the treatment is qualitative, and here is the multiple comparison that you're going to use on the basis of your preference. And again, here is a linear regression model. So if it's false, so we are adjusting the linear regression, and if it's true, so we are adjusting the non-linear regression. And here is hvar, which stands for checking of homogeneity of variance or homoscedasticity among the groups. And here is the sigT, which calls to 0.05, which stands for the mean comparison level of significance, which is the default is 0.05, and the sigF, which is for F table of ANOVA, and the default is 0.05. Then let's import our data, and in order to save our time, I already imported my data, which is similar to the previous one. So we are going to omit the replication column, and here is the genotype, which is a qualitative treatment. And again, we also have here is quantitative treatment. That means in terms of numerical, while is in terms of letter or ABCD or anything. So you can assume that as a qualitative. Then the remaining, that means starting from the column 3 and with column 17 are our response variable, but we only see the pH, which stands for plant height. Then let's run using the tukey test. So in order to use a completely randomized design in ExpDes package, you have to use the function CRD, which stands for completely randomized design. So that's the basic principle of blocking is not working here. Then here is the gene, which stands for the genotype, and it is a qualitative. So our treatment, and followed by pH. pH is our response variable. And again, also here is a qualitative, means we are telling to R, yes, our treatment is qualitative. Yeah, it's obvious, because as you can see here, H1, H10, H11, H12 are designated by letter instead of numerical value like nitrogen. So then the multicomp, if you remember in the previous tutorial, there are a number of multiple comparison tests like tukey, like Duncan, like the least significance difference, and any other. And again, here is a linear regression. We are considering adjusting the linear regression. So by false is the default. So you are telling to R to adjust the linear regression. And hvar is the checking equal variance among the group, or homogeneity of variance, or homoscedasticity. So type this and submit to our studio. Yeah, as you can see here is the tukey test, and all means starting from H13 up to H5 are not statistically significant because they are sharing the letter A on all groups, so they are not significant. But when we comparing the H13 to the rest of H4, H3, and H10 and H9, there is statistically significant difference among this. And again, here is homogeneity of variance test. The p-value is 0.24. So if the p-value is greater than 0.05, so it is non-significant. Non-significant means there is we are considering the equal variance among the group, or we can consider as what homoscedasticity or homoscedastic. Then again, also this the advantage of this package is to also show you the normality test, and the normality test is usually performed by the Shapiro-Wilkes normality test, and as you can see here is a p-value is 0.004, which is less than 0.05. So the test is significant. Test significance means there is a problem or there is a violation of normality. So we can consider that there is no normality or that our data is not normally distributed. Moreover, we can get also the analysis of variance or ANOVA, and as all of you know that for the source of variation for the CRD or completely randomized design is two. One is the treatment, the other is the residual, and as you can see here is a p-value is 0.02, so it is less than 0.05 and it is greater than 0.01, so it is statistically significant. And here is CV, which is a coefficient of variation, which is indicates that the precision, because the low CV is good, because low CV means we are just low error mean squared, because CV is equals to the square root of error mean squared to the grand mean. So if error mean square is tend to less, so our CV will be less, since it is since they have a direct relationship. So by this way you can perform for the tukey test. Let's add one more test using the LSD test. So you have to use the same function, CRD, then gene is our treatment, maybe it's different for you, and the pH is planted, and here is a qualitative. I'm telling to R that I'm using my treatment is qualitative instead of quantitative. So the multiple comparison is LSD, and even you can change into Han, you can change into Leven test, Bartlett test, and any other mean separation, any other checking of equal variance among the groups. So type this and submit to our studio. Yeah. So as you can see here, there is no statistical difference among this group because they share C across all. And again, this treatment is not statistically significant with this one because they are sharing B common. So when later shared among the group, so we're considering there is no statistical significance different to that particular group. And for instance, here is A and AB, so there is no statistical significance difference among the two groups because letter A is shared by both. But if you compare A to BC and the rest one, it is yes, statistically significant. Yeah, similar thing. And lastly, if our treatment is qualitative, so here is nitrogen is in the form of a number, as you can see here, and nitrogen here is 0, 25, 50, 75, 100, 125, 150, and etc. So let's show you this one. Yeah, up to 300 rate or 300 kilogram per hectare. And here is the response variable is pH, and qualitative is equals to false. So we are telling that our treatment is not qualitative, and instead it is what? Quantitative. So all things are similar, and type this and send it to our studio. Yeah, so you can't get any multiple comparison among the treatments. Yeah. So this is all about today's tutorial regarding to the completely randomized design using the experimental design or ExpDes package in our software. Thank you for watching. Bye-bye.